Hey, everybody, welcome back to the Open Generation 5G Summit. The morning has been a treasure trove of information on government, industry, and 5G use cases with some of the top experts in the field, as well as the announcement of the first 5G enabled unmanned aircraft system range. Leila, can you tell us what we have to look forward to next?
Yes. Hi, everyone. Welcome back to this session. So in the previous session, we introduced the topic of use cases and how drones were chosen as the first use case by OpenGen. As In this session, we are going to focus on the architectures, 5G architectures, and how they can enable advanced use cases. So as we move to more complex operations, particularly beyond visual line of sight, there is a need for drones to operate over networks, and 5G brings new capabilities which will allow for better connectivity, throughput, latency, and support to complex operations. So the focus of this session is on architecture, and I would like to now get back to Ajit, who will introduce our next speaker.
Me again introduce Thierry Klein, who is the Vice President of Enterprise and Industrial Automation Research Lab at Nokia. Nokia is a founding member of the Open Generation and is contributing to our 5G UAS range with network equipment. Thierry is also leading a global research team dedicated to applied research, innovation, and advanced technologies within Nokia Bell Labs. Again, I'd like to welcome Thierry.
So again, thank you very much, Ajit and Leila, for the opportunity to speak at the Open Gen Summit. And it's really a pleasure and an honor to be here today, but also be part of this fantastic consortium of companies and academia and industry stakeholders. I want to talk a little bit about the future of drones and how we power that future of drones by 5G connectivity. But before I get to talk specific about drones, I want to take a step back and talk a little bit more broadly about industrial automation. You could go to the next slide, please. So when you look at the industrial automation, and we're really in the next industry 4.0 or the next human industrial revolution, it's all about increasing safety, productivity, and efficiency. And of course, with previous generations and previous industrial revolutions, it's also been about increasing safety, productivity, and efficiency. And those are the common themes that we see every time we have advances. But what's really different now is we're accelerating the speed at which we deploy these solutions. We're accelerating the real timeness of the solutions. We're looking at a lot more data. We're increasing the complexity of the systems that we're trying to optimize and automate. And all of this is happening through data processing, intelligent decision making, automation at an unprecedented scale. I think this morning we also talked about potentially monitoring the entire Earth. So we're really talking about increasing real time, increasing complexity, increase in scale. But when we look at how this next wave is happening, and I like this particular chart from the McKinsey Institute, where they talk about different waves for industrial automation. And the first wave is really about how you build infrastructure. It's all about how do you connect things? How do you enable the different sensors, machines, as well as people, spaces, environments? How do you ensure that they are connected and you can collect all the information that's present that allows you to make these intelligent decisions and automate things? And then the second wave is really about harnessing the power of that data that you're collecting. All the information that you gather, what does it mean? How do you get information and knowledge out of the system, out of the devices, and then make intelligent decisions? So we get into the space of software, analytics, platform, security, and so forth. And then finally, the third phase is once we have that, we believe that this will open up completely new business models. And these three waves, we've seen them in the commercial, in the consumer space. If you think about what's been happening, the first wave, we built out the internet. Then second wave, we had search like Google, we had Yahoo, and so forth, and Amazon. And then we get into the business model. We created completely new business models that were not thought of before, if you think about Airbnb and Uber. And while this has happened in the consumer world, the next wave is really about doing this in the enterprise and industrial space. And arguably, right now, we're in phase one and really at the cusp of phase two, where it's really about still building out the infrastructure, connecting everything, making sure we connect and collect all this information from the devices and machines in the most reliable way, so we can then make the intelligent decisions and move the applications and services forward. Next slide, please. So now you will ask me, like, well, we already have robots and machines, so what's new in the future? What's different from today? We already know that we have robots and self-driving cars and machines in enterprise industrial environments. But I would argue that today, by and large, the machines and robots and drones being a particular example of a machine and a robot, they're very isolated. They tend to be specialized. They generally are not connected and don't communicate to each other. And we develop bespoke applications that are customized on that particular machine for a particular task. And by and large, we built machines that are optimized for the individual machine. But ultimately, the world is much more complex. The applications are much more complex. The environment is more interwoven between different applications, different machines. And it's really an imperfect environment. And we should not forget that also people operate in the same environment. So what we really need is we need a collection of machines, robots, drones talking to each other, being collaborative, cooperating, not just avoiding collisions, but really working together to perform complex tasks and services that we as people would like to see happen. And ultimately, it's about optimizing the entire system for the collection of machines. And of course, the tasks that we would like the machines to do are also very dynamic. They change over time. We create new tasks. So we need the entire system to be very flexible, very adaptive to the environment in which they operate in, as well as the expectations that we as people have on the machines and the robots. And when you think about the task we would want people to do, it's really, they would fall into two categories, I would say. There is one set of tasks that are all the things that we as humans and people that we know how to do, but we just don't want to do them. Maybe they're boring, they're laborious, they're not really interesting. So we could do them, but we just don't want to do them. The second set of tasks are all the things that we would love to do, but we're just not able to. Maybe physically we're not able to perform the tasks. They're too difficult, too complicated, and we just may not have the physical strength to perform these tasks. So when you think about all these tasks, they happen to be in these complex environments where we're just not able to perform them. And I call that really an imperfect world where there are complexities, unforeseen events, people interacting with these environments. Not everything is connected. Not everything is under control of a single entity. And these machines, these devices have to figure out how they navigate that world. If you think about the example of autonomous vehicles, it's actually quite straightforward and quite easy to have a vehicle drive autonomously in a very controlled environment, say on the test track or in a very limited scenario. But it's a very different environment to put several autonomous vehicles into, say, Times Square, where they need to navigate Friday night traffic with lots of people, different vehicles, some autonomously connected, some not autonomously driving. So it's a very, very difficult environment. And this is really the future that we want to enable. And this is really the future that is possible because we have a lot of the new connectivity, computing, and edge technologies. So I want to come back to the question that was posed this morning: are drones the most complex use cases? And I would argue, yes, they are. Granted that drones are flying higher up off the ground and they don't face the complexities that we have on ground robots, for example. But we should also remember there are the outdoor drone use cases, there are indoor drone use cases. Ultimately, if we look at payload delivery applications, the drones would come closer to the ground. They would have to navigate between buildings, in environments with people. And ultimately, if we assume success and we imagine a future where we have lots of drones, it's not about a single drone performing its operation. It's about the collection of drones working together. So I do believe that drones are a very fruitful use case that really allows us to push the boundaries of technology, allows us to validate the current technologies that we have, and then understand how we need to improve, how we need to innovate to really support these future use cases. So if you could go to the next slide, please. So what does that future of drones look like? So my vision, and I don't want to speculate on a time frame, is that we will have a future of fully connected, fully autonomous swarms of drones that are dynamically performing a variety of different payload applications and use cases. And all the words here are really critical. These drones will be connected. They're not just flying autonomously, but they are connected. They're connected to each other. They're connected to the rest of the world, and they're connected to other systems that, and they're ultimately connected to people. They are flying, they're autonomously operated. Without human intervention, humans can intervene if need be, or if they so desire to do so. But the drones have to be autonomously operating just because of the scale. We cannot have one human operator per drone. It would just not scale to the level of the number of drones and the number of use cases we want to deploy. The swarms of drones doesn't necessarily mean that these drones are all the same or they're operated by the same entity. You have multiple different types of drones, multiple operators, not all connecting to each other, not all aware of each other potentially. And still, the overall system as a distributed, decentralized system has to work safely together. And then there are a number of different use cases. The same drone might be performing different applications at different points in time. How do we enable a particular system of drones to perform a variety of use cases in the most efficient way? And some of the use cases that we're looking at in Open Generation Consortium are around payload delivery, emergency response, inspection, as well as indoor drone applications. And we picked these 4 use cases, not because we think that they are the only use cases, but they are canonical examples of the larger set of use cases that we envision for the future. And they have the unique characteristics that are representative of a much larger set of use cases, both in terms of the requirements from the network perspective, as well as the requirements from the application and the payload itself. But of course, there are huge challenges with this vision of building such a swarm of drones. The first is we have to operate on very large areas and very often beyond visual line of sight. These drones have to operate in an environment where we have people. And ultimately, we need to understand what the regulatory framework is to support these drone operations. And we have to have the environment to support this from a business perspective. Because ultimately, if we have the technologies to enable this vision, but the regulatory framework is not present, the applications will not be deployed. And if the business environment is not present, and it cannot be done in a cost-effective way, the applications will also not be deployed at scale. So now the key part is really, the first part I would say is really to connect the drones. Of course, the drones are wireless, or are flying autonomously, so they have to be wirelessly connected. So let's go to the next slide saying, why is it so hard? What's difficult with connecting drones? And I was reminded of this cartoon, this Dilbert cartoon from several years back, where saying, well, how hard can it be not to connect wires? And it's just a drone. Why is a drone different from a smartphone? Why is it hard to do this? So let's go to the next slide, please. And really the key starting point, and I think a lot of what we do from connecting drones over 5G network really comes down to this one fundamental point that drones are flying at different altitudes. And that may seem like a small point, but when you look at it, the drones flying at an altitude that's, say, above 100 meters, when typical mobile phone networks that we use every day today are built for consumer mobile applications, mobile phone applications, where you typically hold your phone at 1 meter to 1.5 meters, 2 meters above the ground. And that creates a lot of challenges where the drone, or seemingly different environment that has challenges or opportunities, you're not interfering with buildings. You think it's a cleaner line of sight from the drone to the tower, and that has impact on the propagation environment, because the drone will see line of sight to the base station as opposed to the clutter and the fading and reflections and obstructions from buildings. So this is really a key point. But now you can say, isn't that a good thing? Isn't it good for the drone to have line of sight to a tower? Why is that a challenge? We go to the next slide. On this slide, I want to highlight some results that the Nokia Bell Labs team has done in Denmark, where they've flown a drone at different altitudes and just measured how many different cell sites they would see. And so you can see on the chart on the right, you can see that when the drone is flying at 1.5 meters above the ground, which is the typical height at which you would hold your smartphone, you see on average about five cells, 5 base stations. When you fly the drone at 120 meters, which is the red curve, you see on average 20 cells, or 20 base stations. So the higher you fly the drone, the more cells you will see. And again, it seems like a paradox that this would be a good thing. The more cells you see, the better your connectivity should be. We've all been in situations where we lost the signal and we said, I wish there were more base stations around here and it would have a better connectivity. So why is this really a challenge for drones? If you go to the next slide. What really happens is we look at 2 applications, the 2 critical applications, one on the downlink, which is when the network is transmitting to the drone. If you look at this picture on the left, the drone is connected to that bottom base station on where it's labeled the C2 link, which is for the command and control. That's where the drone would get its signal for controlling and directing the drone. But because the drone is now in line of sight of multiple base stations, it also receives information and signals from all the other base stations that are not controlling the drones and are not sending information to the drone directly. So that creates a lot more interference from all the other neighboring base stations. So while it would seem to be a good thing to have more cells and more base stations in the view of the drone, it actually creates potential for more interference. On the reverse, on the right side, when we look at the uplink, which is the application, say the payload application from the drone, for example, a streaming video application, if you think about an inspection or monitoring application where the drone is performing an inspection task, streaming video to the network, the fact that the drone is also seeing multiple base stations has the potential for creating interference to the rest of the network. If we think that this is a network that supports drone applications as well as mobile phone applications, the drone sending its video on the green link to the base station in charge will also create interference on the other 2 base stations on the red links. So again, what seemingly is just the fact that the drone is flying at a higher altitude as just a key differentiating characteristic, now we see that the consequence is that we're creating potentially more interference that could be limiting to both the command and control application as well as the payload applications. And the question is, what can we do about this? If you go to the next slide, I want to highlight essentially two areas and 2 types of approaches that we're looking at to mitigate this interference and ultimately optimize the network performance for the drone applications. And they would fall under optimizations on the radio access network, and I would say network architectures and network-wide optimizations. When we first look at the radio access network, there's a number of technologies, a number of techniques being considered, implemented already in the standards in release 15, and then further going forward to release 18 and beyond. And they have to deal with things like higher frequency bands. We're looking at millimeter wave applications, looking at beamforming applications to really direct the beam towards the particular drones and limit the interference to other devices that are connected on the network, coordinating the interference, trying to mitigate the interference through smart resource allocation specifically for the drones. That includes, for example, techniques like separate power control algorithms for the drones, on-demand power boost for drones or other devices connected to the network, enhanced machine learning techniques for scheduling the transmission, again, to the drones or to the other devices that are connected to the network, and ultimately doing a more coordinated resource management and interference coordination across not just one base station, but the multiple set of base stations, and expanding the set of base stations that are part of this coordinated interference and resource management. So again, a number of technologies that are being worked on the radio access side. And with OpenGen, we definitely want to validate and test a lot of these technologies out with the test beds that we're creating. When we look at the network side, so beyond just the radio access control, we're looking at network slicing. How do you create dedicated slices for the control of the drones, dedicated slices for the application, and really separate the drone control from other applications that are running on the network. How do you do end-to-end quality of service optimization, not just on the air interface link, but really end-to-end for the drone control as a whole? Interesting ideas also, knowing that the device that we're trying to connect to is a drone, we can also predict the flight path. We may have information of where the drone is going, and that can be used as part of a predictive resource allocation, on-demand coverage optimization that take explicit information into account from the application being a drone into the radio controller. And some of the new network architectures, such as the ORAN architecture, will facilitate some of those on-demand enhanced resource management schemes. And then the final point I'd like to make is we should also look at new network architectures. We can, of course, look at the terrestrial networks that support the drone applications and look at optimizing, configuring the terrestrial networks for best performance of the drone applications, but we can also look at different network architectures. For example, put base stations on drones themselves to provide the capabilities for certain use cases. Look at high altitude platforms that could be a control node for the drone application, such as shown in this picture, where the platform in black would be basically a base station for the drones that are flying in the area. So how do we build hybrid networks? How do we build new networks that are optimized for the drones and used in conjunction with terrestrial networks? Is a very fruitful area for research and innovation. If you go to the next slide, I want to talk a little bit beyond the radio access network and the connectivity itself. At the beginning, I talked about the applications and how do we enable a system of drones. And there are really a lot of system considerations that go very much beyond connectivity. And for example, I want to talk about 3 particular topics that are important for successful, safe, and reliable operation of drones, but they also have ties to 5G and edge computing. The first one being precise localization and positioning of drones. It's really important to know where the drones are, and so we can take that information into account into the resource management control, but it's also really important for collision avoidance and orchestration of the drones and the payload delivery, for example. Again, we are looking at 5G precise positioning technologies, but beyond RF-based localizations, we should also look at other technologies for localization and positioning of drones, including, for example, video-based localization, acoustic-based localizations, and other modalities, and then ultimately fusing these different modalities to have the most reliable, most accurate information about the location and position of the drone. And this is particularly important when we talk about indoor drones where we don't have GPS. So in any environment, indoors, in mines or urban canyons where you might have GPS-denied conditions, how do we locate drones? And so we have to look at other modalities to be able to safely identify where the drones are. When we talk about swarms of drones, and the coordination of drones will become very important. A drone may be able to operate and perform its mission on its own, but the coordinated path planning, coordinated scheduling of tasks, as well as then collision avoidance between the drones will rely on broader situational awareness about the entire drone system. And that will be best done from the cloud, where you have much more information about the entire environment, including other systems that may be operating in the environment as well. It could be ground robots, it could be other non-connected devices. So we think that the fact that we have the 5G connectivity coupled with edge clouds allow us to have this broader situational awareness and ultimately broader operational control over a multi-drone system. And of course, in a lot of environments, we need a human operator, either for safety reasons or as a backup pilot, or just for teleoperation of the drone, because we're getting into a very specialized operation, very specialized application, including the maybe some payload control. For example, for inspection, you might fly a drone to a particular area, but you need an operator to look at the video that comes from the drone to to analyze the situation on the ground. So being able to facilitate that remote operation of drones, the network will be very, very critical, as will be the human drone interface. And then finally, I would say the payload application is really critical. We talk a lot about the control of the drones, but being able to perform useful functions with a drone, whether it's a payload delivery or package delivery, whether it's an inspection, whether it's a video-based application, other type of sensor that may be on the drone to collect information about the environment. It's really key that we also have the network capabilities to get that information off the drone and to a system, a person that will then ultimately take the decision of what to do with the information. And some of the interesting questions there are about what part of the application do you run on the drone? What part of the application do you run on the cloud? You certainly don't want to stream all the information to the network and just perform no processing at all on the drone. On the other side, if you perform all the processing and compute-intensive AI, ML, machine learning models on the drone, that may also not be possible based on size, weight, power constraints on the drone. So having a flexible architecture that allows you to offload certain functions from the drone to the cloud, perform some other functions on the drone, and do this in a flexible, adaptive way will be key in the future as we're deploying these payload applications. So if you would just go to the next slide, that would be my last slide. I just want to conclude that I believe that we have a lot of technologies in our toolbox right now, starting with 5G, edge cloud, edge computing capabilities. We have these tools, we have these technologies, but of course, we need to test, we need to validate these technologies for the new drone applications, identify really where the boundaries are, identify where the limits of the technology are, and then push forward, push beyond those boundaries, invent new technologies so that we continue to support this vision of autonomous drones in the future. Ultimately, this is all about an ecosystem of stakeholders. It's not just the technology stakeholders, it's also the business stakeholders, it's also the regulatory and legal framework has to be in place to support the future applications. If we only focus on the technology, we will do this in research labs and research test beds. But how we go forward from the research, from the test beds to commercial deployments is key. And so we need to work together as an ecosystem to be successful. And OpenGen is just a fantastic environment to do that across multiple companies, multiple universities, environments, to really advance this collectively for all of our benefits. And I would say collaboration always beats autonomy, not just in the technical sense. I really believe that when you look at individual systems that collaborate will ultimately always be more successful than systems that don't collaborate. But I also mean it from an ecosystem perspective. Any one of us could work on parts of the problem, but we could not possibly solve the entire problem on our own. So working together, leveraging each other's different expertise and experience, solving the problems together, and ultimately addressing the unknowns and the gaps together will be key to success. And I'm very excited about what we've already been able to accomplish with OpenGen in the past year. And I look forward to working with everybody in OpenGen, the current members and new members that might be joining us to advance this further. And I'll stop there and be not sure if we have time for any questions. But thank you very much for joining today.
Thank you very much, Thierry, for the very good presentation. Several very important points that you made. I would like to ask Ajit to tell what were the key takeaways that you got from this presentation.
Yeah, Leila. So for me, I was just taking some notes here. So I think in the beginning, Thierry talked quite about the waves of industrialization and how we're entering that third wave. And this is an opportunity for the use cases that are going to come out of that will have even a greater impact on people's lives and on industry. The other thing that I noted as well was that he talked about I think we think a lot of times about drones as singular objects in the air, flying on their own, but this whole concept of drone swarms and them drones needing to be able to communicate with each other in the network, using the network and being able to fly in a coordinated fashion together, even beyond just doing laser shows, but to actually be able to accomplish tasks was also another interesting area that Thierry brought out.
Yeah, great. Yeah, and just to add to this last point on the need for the drones to work together, and I mean both on the swarm environment and also in when they are not being operated. I mean from the same operator, but because of the density of drones that we may get. So I think it brought to mind the need for a lot of increasing information sharing through the operators and all the systems that will allow that to happen in the background across different systems, different operations. And how one other point that Thierry made was how hybrid levels of automation will be a huge challenge as well, right? Because you have different types of operations at different levels of automation. And I loved that the little robots figure with the different tools, the collaborating robots. Very nice.
So I would like to again remind everybody we have some polling questions that are active. We hope you will all be able to participate in that. And we'll get moving now to our next session for today, which is covering new frontiers with 5G architecture. And that's moderated by Jerry Libano. Leila, would you like to introduce him?
Yes, so Thierry Libano is a distinguished engineer at Verizon Communications, supporting wireless standardization and industry engagements, and a key member of Verizon's Advanced Technology Strategy team. He's also the primary GSMA North America contact for Verizon and active in GSMA working groups and initiatives. Jerry is currently focused on the future evolution of the 5G network architecture for IP-based services and applications across industry verticals, including 5G drones. Welcome, Jerry.
Thank you, Lila. I'm glad to be back. What a day we're having. So we heard from this morning the mission, right, of how the consortium can make a big difference, on 5G. We went through looking at perspectives and insights to use cases, even in a debate on which one and when they will take place. And hearing Thierry giving us a preview of what we're looking at, as far as developing the architecture in order to support all of that. Now we have to roll up our sleeves and see, what kind of architecture, do we need in order to fully realize a true drone economy at scale. So with that, if we can get to the first slide. What is a 5G drone? Is it a plane, pilotless? Or do we look at it as a smartphone? I think this simple question underpins a really complex scenarios. On the left side, we're looking at aviation, which in perspective started with the first commercial flight back in 1914 and reached availability as far as commercial flight, towards the end of 1950s. And if we look at drones, we get to the military use, U.S. military use around 2001, with availability to consumers, recreational use around 2006, and a year later, we get to see the first commercially certified use of drones in terms of package delivery. Now, on the other hand, on the right side, if we look at and see where things are and how we arrive at it, we look at the first commercial use of a mobile phone in 1983. And I would consider the launch of the iPhone in 2007, as well as the subsequent deployment of LTE networks, as really the turning point in terms of unleashing the true power of the internet, using the pervasiveness of the cellular network to include the inherent security built into that, as well as making sure that user privacy is upheld. And now, fast forward, we are looking at 5G, and beyond what we're used to in terms of consumer and uh, enterprise use of voice and data network. We're looking at really a far-reaching transformation of the different industries, and how the drone play into this is really pretty amazing. So the question earlier today is UAS the truly defining use case that we should take on, that makes a lot of the other uses of 5G, uh, easily tackled. So that's the question that I think we have to look at wearing now our architecture hats. And on to the next slide, the question then becomes, how do we bridge, both domains? Where on the left side for aviation, it's all about safety, and on the right side, it's all about making sure that we take where we are right now in terms of consumer wearables, IoT, using the internet speed, as well as the scaling of what the public clouds would provide, uh, get to combine all that in terms of creating what we refer to as a true drone economy. So on the left hand side, to ensure the safe integration of drones into the national airspace, we've actually heard earlier mention of command and control, or C2, detect and avoid. Uh, we have UTM and USS, which is really a vision that NASA had, that FAA fully support as well. And this is infrastructure, that we don't have today, but we have to make sure that gets built in order to allow for a true scaling of the big number of drones that we anticipate. So it safely work with aviation as we know them today, and it also safeguard structure and lives, so no one is injured if a drone suddenly, as was mentioned earlier, because of gravity, drop downs on Earth. And of course, more recently is the use of remote ID to make sure that we can identify a drone and make sure that it's safe and doesn't pose a threat. So if we go on to the next slide, and we've seen a lot of this today and tomorrow. Um, what makes 5G uniquely differentiating from 4G and the previous generations is the fact that this is the network that was built from the ground up, already taking into account a service base and a cloud native architecture. And as far as unique capabilities, we have next generation magnitude, order of magnitude of uh, peak data rates, throughput, extremely low latency, high reliability, and being able to support a massive density of devices in a given area, as well as being able to provide for a quick way of deploying them. At the same time, going with green, energy efficiency. Now, this is happening at a very timely moment because we also find ourselves with convergence of breakthrough technologies, as you can see on the right side, cloud and edge computing that will realize different operational models and really bring this into what we're looking to accomplish with the architecture, a quick scaling, so we can actually realize the benefits of this across enterprises, industries, government, public safety, etc. But at the same time, a lot of this, will also provide data, real time, not real time, not just in the control of the flight of drones, but as important, taking this data and bringing the perspective of what does it look like, looking from the sky down, and how we can actually combine this into creating a 3D map, of the world. And that was also mentioned previously in the course of the day. Uh, Now, there's a lot of, mention of autonomy as well, pilotless as an example. So AI, artificial intelligence, and machine learning, brings this about, as well as augmented reality or extended reality, and the experience that it can provide, not just from the industry, but how a drone or a flying vehicle can make that available. Uh, Now, very important for we are is actually making sure that it's cyber secure, and all the components that go in the drone, whether it's firmware, hardware, is fully secure and doesn't create problems for the business that use them, for folks that actually operate them, and for the end user that gets the benefit of all of this. And Now the question then is, how do we bring this and how do we combine them into the architecture that we're building, starting with focus on 5G connected drones? So next slide, please. Okay. So transformation of industry, scale. But exactly how do we achieve this? Uh, so I've mentioned about safety and the fact that the architecture should focus on the very fundamental requirement of a safe airspace integration, already looking into uh, requirements driven by regulatory around uh, the use of uncrewed aerial traffic management, remote ID, and beyond visual line of sight. At the same time, looking at key emerging commercial use cases in key industries. We've seen that from Thierry's keynote. And how do we create scale, combining 5G with public clouds and putting edge computing at through internet speed? We can all, of course, accomplish that, if we start with safety as what the first bullet, was saying. Now, earlier, there's also a key takeaway that I had in the use case discussion, which is the public, is a citizenry, prepared, for what's to come. Uh, and a big part of what the consortium does, enabled by the architecture as well as this pipeline of innovative solutions, would be a way to demonstrate this value to businesses large and small, but as well as to the public. And one thing that is also unique with the effort that we're doing is we're working with the best of the academia, right, to enhance the architecture that we build, but at the same time, bringing about a pipeline of innovation fresh, so we could actually ensure that we're not limited in terms of our imagination as well as our ambition in terms of what we want to create and drive. Now, lastly, a very important part of what we do that lends to the drone corridor, as was mentioned earlier, is making sure that we work hand in glove with the public sector, after bringing in the industry and the key stakeholder, right? And all these investments flowing into 5G trials with certainly a path to commercialization and regulations in place. So if we can do all this in the course of time, right, then we will be stepping closer to making this happen, right? Now, that said, not as a bullet in the slide, we know that a lot of things will have to happen, right? So what I'm hoping is, as I get to the panel discussion, we can start to peel, what those are, because there is, industry even from the GSMA side in terms of how we will integrate all this as well. So next slide, please. And this is my last slide. What we're trying to do in the consortium is build or develop a 5G architecture, though starting with 5G drones, but already will take, all the different aspects and capabilities of 5G as a foundation. At the same time, it should already be incorporating the breakthrough technologies that we just went through. So the question then becomes, do we have an architecture that is flexible, extensible, future proof that we can improve on as we look at the other targeted vertical that we have in the consortium, starting with autonomous vehicles, using vehicle to everything capability that 3GPP has. Not to mention smart cities, healthcare, digital divide, and green 5G that in themselves already could be transformed with connected 5G drones. What is unique with the first one, the autonomous vehicles and 5G drones, is that we're looking at the same autonomous, pilotless drones. Even though the regulatory regime, may be different in each of those two, but in reality, they're all vehicles, one on ground, one up in the air, and one can also point out that there are drone boats or vehicles on the surface of the water around a marina or port. Uh, and what that simply says to us is, there is a quick opportunity to actually, with one stone, in the consortium, cover 5G drones and quickly getting onto autonomous vehicle, looking really at multi-domain support. And at the end of the day, this is what brings the economy of scale across all these verticals. So I would pause here, and I would now take pleasure in introducing my panel. Okay, so I am joined by Dipesh Modi, a lead 5G core network research engineer at MITRE, Javed Khan, director, 5G RAN product management at LGStar. Last but certainly not the least, Devaki Chandramuli, head of the North American standardization at Nokia. Would I like to request each one of you in the same order to briefly introduce yourselves?
Okay. Thanks, Jerry. And myself, Dipesh Modi, lead 5G core network research engineer at MITRE. And as we know, MITRE is a non-profit organization solving problems for a safer world through FFRDC. We work with governments, industry, academia, and the objective is the safety, stability, and well-being of the nation. Within MITRE, I work at MITRE Labs. We carry out 5G experiments. Before that, we actually building right now 5G capabilities for standalone network with the ultimate goal of supporting 5G network slicing, 5G authentication framework, and the most important one is the zero trust architecture with the security within the 5G core network and the RAN network. We are also looking at orchestration and a lot other things which 5G can offer and support our government-sponsored projects. At the same time, I also work with MITRE OpenGen, currently chairing the architecture and solutions working group. And MITRE Engenuity, MITRE OpenGen, as we have heard in the morning, it brings the industry together. The objective is the R&D partnership. We carry out experiment at the ultimate goal of how 5G can solve the problem which exists in other industry. And it's not simply possible that one company can solve all the problems. So we try to work together and collaborate on this thing. Within the MITRE Engenuity OpenGen, we are right now involved in creating architecture framework for supporting the US over 5G network, but with the goal in the mind, as Jerry mentioned, look at the future verticals also at the same time. So that has been the goal. We are working towards that goal. Within last year, we have focused on creating the framework, working on solutions and design. How can we carry out the experiment, defining the details on that. Last year, you may have seen in the morning that we actually carry out some experiment at Virginia Tech drone cage with the partnership of Virginia Tech and CCI team. And we just published a report with the more details on that. Going back to before MITRE, I have 25 plus years of experience working in telecom industry, working for communication service providers, technology suppliers, and I have worked throughout the enterprise wireline and wireless solutions. The whole objective I have been to experimenting new use cases, design and architect the network, at the same time supporting the operation, how things work in the real customer. So bringing all experience together, and I think this is time to try how 5G can help solve all those problems. Thank you.
Javed?
Yeah. Hi, this is Javed Khan. I'm a director of 4G and 5G RAN product management at LGStar. Here I'm responsible for RAN product management, including private networks and enterprise and small cell products. I've been here. I'm a recent. I've been here only about a year. Prior to that, I worked for Nokia for about 9 to 10 years in their mobile networks division. I worked in system engineering and product management of 4G and 5G RAN products. And prior to that, I worked for Motorola for more than 15 years in primarily system engineering on a number of projects, including starting from Iridium to CDMA and LTE. A little bit about LGStar. LGStar is a vRAN solution provider, and some of you may have heard that was recently acquired by Rakuten. So we are now part of Rakuten Symphony. It's a new company that was created, which supplies 4G and 5G RAN and cloud infrastructure, and services and solutions that go along with it to telco operators. We provide a unified cloud-based vRAN solution, including service orchestration, automation, the OSS, and other components that build a full-featured Open RAN solution. And in fact, LGStar Open RAN solution has been commercially deployed in Rakuten in Japan nationwide. So it's been deployed at scale and in other networks around the world. I'm really honored and to be that LGStar is part of the MITRE OpenGen consortium. I represent LGStar in several working groups here, primarily in the architecture and solutions working group. And I've been working with Dipesh and the team on developing the architecture and solution to support the US use cases. So I'm glad to be here.
And Ivaki?
Thank you, Jerry and everyone. I'm really glad to be here as part of this panel. I have over 20 years of experience in the wireless technology, initially with Nortel, currently with Nokia. I'm Nokia Bell Labs fellow, heading a team for North American standardization and industry engagements. I'm also a 3GPP delegate, lead and rapporteur for the 5G system architecture specification. We are proud to, Nokia as a company, we are proud to be a founding member of MITRE OpenGen, and we also contribute very actively and drive features in 3GPP for 5G and now going forward for 5G Advanced. Thank you.
Let's try to make our conversation this afternoon interactive. So I'll direct a question to each one of you, but feel free to add if you have perspective or insights that you want to share as well. So I'm going to start with you, Dipesh. Um, drones from an aviation perspective, we have safety as primarily, the utmost, concern and importance in a highly regulated environment at that. Can you take us to the relevant standardization activities in support of the FAA requirements and how we factor all of them into the 5G drones architecture that we're developing?
Okay, thanks, Jerry. So let me just quick overview on what kind of things we are considering first. With the drone technologies, there are some key words we need to be familiar with. C2, command and control. We talk about DAA, detect and avoid technologies, and remote ID, how the drone can provide a location and ID information back to the network so we can track it. At the same time, we want to know about the position, location, velocity, a lot of other things. There are all those key factors. And FAA has policy to make sure that the airspace is safe, we are following the rules and regulations, and we can fly over the people safely. RTCA is one of the standard organization. They work directly with FAA to develop comprehensive and industry-vetted standards, which can be used for the compliance with FAA regulation. And as you know, within the RTCA, there are a couple of important standards for the performance standards. We should keep an eye on it. One of them is the minimum aviation system standards, which primarily focus on the system, not individual components or equipments. And there is another one for MOPS, which are mainly focusing on the equipment side, but minimum operating performance standards on that. RTCA Special Committee 228 is primarily focused on a minimum performance standard for UAS at the system level and define the MOPS. The one we kind of considered are the DO 365 for the DAA system, which was published early this year. Another one to keep an eye on is a DO 362, which was done for the C2 data link for terrestrial and maybe for the satellite access. There is a future work happening on this standard for the cellular, so we are keeping an eye on it. DO 377 is another important one, which is for the C2 link system for the US, which takes care of the ground control station and UAV at the same time. DO 377 also, we are expecting in a couple of years the next phase to come out. So these are the RTCA 3 standards we considered while designing the architecture for the drone for the aviation industry. Besides that, we also look at the ASTM. ASTM is American Society for Testing and Materials, international standard organization. They kind of publish standards which may be referred into FAA regulations or order, but not required. But they have a lot of weight. That it is used a lot. ASTM, one of the important one is F3411. This is the performance requirement for the remote ID for the US. There are two parts of it, broadcast and network. We are focused on a network because which is directly relevant to the 5G network. And another standard on the STM perspective is F3442, which was done in 2020, focuses on the DA architecture, but primarily focusing on the cooperative traffic. And in the future, they may address the non-cooperative traffic. So there are a lot of standards to consider from our RTCA ASTM, but at this time, in the first phase of the architecture, we are looking at all the standards. The members participate in various committees, so we have a great insight and also opportunity to make a difference in the future.
So, Dipesh, quick reality check, right? So there are a lot of things that will have to happen in the space that you mentioned, RTCA, ASTM, and the work in progress. And to a lot of extent, as you also pointed out just now, that even with RTCA, that would take a couple of years before they uh, specify the minimum for performance, requirements, operational requirements using cellular technology. Doesn't that prevent, the consortium to actually not include them in the architecture? Or do you see that there is a unique opportunity for the consortium to already anticipate, and do something, right, in advance of those, but at the same time, depending on the results that we attained, can even furnish them, right, to make sure that we accelerate. Because otherwise, if we wait another 2 or 3 years, seems like an awfully long time. But there's a way that or maybe a reason why they move slowly, as far as ensuring interoperability and safety compliance, right? But with that said, what is your view to that?
And I think that's a great point. The reason is that standard work at their own pace, industry work at own pace, and now we are talking about combining multiple industry together. There are standards being developed in aviation. There are work going on in 3GPP. Everyone is looking in the future. If we wait 2 years for aviation to come up with standard, and then we go back to 3GPP and get those requirements 3GPP, that's simply not practically possible. We can't wait 7 years, 6, 7 years for one feature or functions to be available. So we are looking at what's available today. We are going to take the existing technology into the field. We are going to conduct experiments, and we are going to stress the system at a level so we can try to address what is the minimum required today and how can we make it better today. In all those experiences, we may learn something new. We may figure out 5G is way advanced than what aviation needs, or we may find other way that 5G doesn't even support what they want. But that's we need to carry out in the field, and a lot of member participating at the same time, bringing the experience from the both industry and see what happens. We have already conducted one experiment last year. We are going to conduct again, as advertised in the morning today, with the new air site. We want to carry all those things in the field, learn from those experiments, create the reports, and make sure we can make aware the public. You have the standards coming in 2 years. There are opportunities of improvement here. This is where we can address in 3GPP. These are the technology challenges which we need to figure out. We need to work at the same time. We cannot wait for standard to mature and then go back and do experiments.
Okay. Yeah. So the least that we could do, right, is also take into account that the architecture that we develop is flexible and malleable. That as the standards get, specified and completed, right, that we could easily incorporate that. Of course, uh, we're looking at implementation deployment, hopefully within a couple of years. So there's investment to protect, right? But we have to make sure that the architecture is actually able, to adapt to these changes, plus other breakthrough technologies that will, come by, like within the next few years. So Devaki, can you give us an update on the work that has happened in 3GPP in support of not just 5G drones, but LTE and 5G drones in general, and specifically support of the more aviation-specific requirements around remote ID, C2, and DAA in particular?
Sure, Jerry. So in 3GPP Release 17, we worked on the enhancements needed for drones, both for EPS, that is for LTE, and 5G system. As we can imagine, we can expect LTE networks and 5G networks to coexist definitely in the near term. So 3GPP took a practical approach to specify the necessary and essential enhancements needed for drones. To start with, 3GPP specified the identification, authorization, and tracking functionalities for EPS and 5GS. And more specifically to your question on remote ID and C2 link and these identifiers, we have the UAV or the device in the drone can be identified by the CAA level identifier. It's called as Aviation level unique identifier. And why do we need this identifier? This identifier is needed to be first authenticated and authorized by the drone system, that is the USS and the UTM. And only after that happens, the 3GPP system provides cellular services for the UE that is used with the UAV. And it is also possible for to perform this dynamic flight path authorization and C2 pairing. And what is the C2? The C2 is basically is the critical communication link for this command and control. So it needs to have low latency support. So we also, 3GPP also provides this mechanism where the device can have a dedicated session or a dedicated slice, which was also mentioned as one of the enhancements needed in theory slides, and with necessary quality of service for these critical communications. And besides this, we also introduced many tracking capabilities that were that can be exposed to these external systems in this aviation industry for managing and controlling the air traffic. Such capabilities can include, for instance, providing periodic location, reporting UAV moving into or outside a certain geographic area, and also reporting the list of UAVs in a specific geographic area. So from a timeline perspective, the stage 2 work is done in 3GPP for release 17, and stage 3 work is ongoing, and we expect stage 3 functional freeze in first quarter of 2022, and then we also expect ASN.1 coding freeze in second quarter of 2022, and that would be the milestone that for implementation to use the 3GPP specification that are ready for implementation.
So just a quick follow on Devaki. Already supported in release 17, would be how the network of USSs, UAS service suppliers within the framework of UTM. Can you elaborate a bit on what's in release 17 for both the 4G and the 5G systems, and how 3GPP specification is looking to help in its integration to the network?
Yes, certainly. So 3GPP supports interworking between 4G and 5G network by default, even without drones, right? And 3GPP also supports inter-PLMN interworking and roaming support. This is all by default, not even drone specific. Besides that, for drones, as you mentioned, we also assume the USS can be interconnected and with the 4G and the 5G network. So to support that, 3GPP specified exposure APIs that can be exposed both from the 3G, 4G networks and the 5G networks. And if the USS requires some service, then it would be transparent whether the user is actually camping in the 4G network or the 5G network. So making it seamless from the USS or the aviation system perspective. But in order for all of this to commercially happen and make it a reality beyond 3GPP, we also need, of course, work in GSMA to enable USS interconnection and roaming a reality, right? So because we can assume that the 4G and the 5G networks will coexist.
So I'm going to pick a question that just came up on the chat, Devaki, but because I think this is in line, to the question I'm asking you as well, right? So this question came from Greg Belows from Jovi Aviation, and it's kind of like noting that it's been a while in release 15 that 3GPP specify the mitigation or enhancements to the LTE axis to ensure that it can mitigate the interference that may be caused by, flying or aerial UEs or aerial vehicles. At the same time, improve, mobility. And from release 15, I know you talk about release 17, and can you touch base as far as insights that you can share with respect to where that optimization at all, if they have been adopted, in particular here in North America? And where do we see the same, happening as far as same, enhancements on the 5G NR?
Yes, so to start from 5G NR, the optimizations for drone-specific optimizations for 5G NR, we expect mainly in release 18, which we refer to as 5G Advanced. And as part of that, we would also see features like measurement reporting, flight path reporting, and interference mitigation being addressed for NR. Those features, of course, the UAV specific optimizations have been specified for LTE from 3GPP perspective. In terms of adoption, I guess this is being I mean, I can only say that this is in the lab. I'm not aware of this adoption or the deployment from a commercial standpoint, which is what we are targeting towards here, right? We would like to see both the enhancements specified for LTE and enhancements that will be specified for 5G NR become a commercial reality by starting with these test beds and all the good work that is ongoing in OpenGen to make it a commercial reality.
Okay, thank you, Devaki. I would also quickly note that as ACGA, or the Aerial Connectivity Joint Activity Collaborative Effort between GSMA and GUTMA, has resulted into a industry position paper that actually profiles what's the minimum implementation reference set that a UE component to an uncrewed aircraft, or what we call drone, as well as what's expected to be supported in the network, are, right? So that's the LT aerial profile. And certainly that was taken into the architectural discussion to ensure that, we have already in place, that common reference set, which quite frankly, ahead of the standardization that will take place, hopefully in release 18 on the same mitigation on NR, would pretty much be, identical as far as having a well-known UAS APN or its equivalent, on the 5G, system, we simply call DNN. So I think there's a lot more, but certainly these are getting factored into the architecture. And Dipesh, a few words to what Devaki has mentioned, because I think that's key, to the first thing that we should do in the architecture. We have to take into account all these release 17 features whose stage 2 has been completed, and now 3GPP is finalizing the stage 3 solution to completion around March or June next year. So can you talk a little bit as far as how these are actually captured in the emerging architecture for 5G drones?
Okay, can you hear me? Okay, good. Yeah, so there is a question, on the chat, which is kind of related to that one, that the standards are being developed. There is a question that they are not being implemented by the vendors, but we are starting effort to get the test bed into the field, where we are welcoming all the options, that we bring the solutions to the table, that we are interested in trying out the release 15 and release 16 and 17 enhancements. If there is an early release, we are considering we can experiment all of those things in the field. So that has been the plan. We are also, as part of the architecture framework, we kind of mainly focus on the use case to start with and how use cases we can address at the same time. At the same time, we also need to look at and plan for the next upcoming release. Either those releases are coming on the NR perspective or the course perspective, but the objective is that we want to experiment early release if possible into the field. Yeah. Okay.
Javed?
Yeah, I was just going to add that the architecture framework that we are developing, is going to be based on what is present in the standards today, and the idea is to use the extensibility and modular nature of the 5G system that has been defined in Release 15 and Release 16, and the fact that it's a service-based architecture. It'll help make use of the enhancements that have been put into Release 17. For example, the network function that have been defined to support UAS and its connectivity to the USS, for example. As a first step, right, is to implement that in our test beds and conduct experiments out in the field and identify areas of improvement, identify gaps in the technology that needs to be developed, and help drive that back into various standards group. And that's not just 3GPP; it also includes other standards group like RTCA and so on. So the idea is to use the test beds to validate our architecture and to use simulation and experimentation to identify enhancements and performance requirements that may not be easily determined through analysis, but rather through experimentation.
So, Javed, let's look at the RAN, right? So, can you speak to the role that O-RAN standards play in the development of the 5G architecture, or anything that you may want to add in terms of innovation opportunities in the radio access network?
Yeah, sure. So before I get to the ORAN part, so the 3GPP itself, the architecture, like as Devaki mentioned, right, all of it is going to be used as a base for supporting drones, in addition to functionality that have been added to support drones in Release 17. That includes the API exposure and the network function that to support the C2 link and the authentication and authorization for drones. Now, in addition to that, the development of edge applications, right, is another important a component that will be used to support commercial drone operations by incorporating edge applications that are specific to drone navigation or path optimization and so on that you would expect to see in a commercial 5G network. Now, in terms of ORAN, ORAN has introduced architectural constructs, and one of the most important ones that would be applicable here would be the use of the near real-time RAN intelligent controller, for example, and how that could play a role in supporting drone infrastructure and optimization in the network is, the near real-time RIC itself, is a platform that is being developed that has a lot of data crunching, AI and ML capabilities, and the ability to optimize the state machines or the functions within the RAN. To optimize, for example, to solve problems such as interference management that drones might see. As Thierry mentioned earlier, right, as the drones fly above the ground, and because it can see a lot more base stations, interference is a real challenge. And the near real-time RIC can play a part there by being able to get real-time feedback on the interference profile that the particular drone may be experiencing, and be able to define new resource or modify the scheduling, for example, in the RAN to mitigate that interference. There may be other features that the XApps on running on near real-time rig can support. For example, path optimization or handover profiles for drones as they fly around, being able to pick the right next base station to connect to, which may be easier to do on a near real-time rig than it would be in a single base station, for example.
Okay, so back to you, Devaki. Help us with your insight on how the 5G system is uniquely positioned to transform basically how we work and live in general, and how these capabilities that will be used across enterprises and different industry verticals come into a big play in terms of creating an economy of scale that will further drive drone economy to reality. Uh, and I believe 3GPP is also looking at a more harmonized framework with capabilities to ensure that this is actually what gets done in its specifications.
Definitely. Yeah, 5G system, yeah, as a whole offers many innovative features that offer benefits for the operators, the end users, and the verticals. And with 5G Advanced, that is actually referring to the Release 18 features and beyond, will offer improved coverage, capacity, and also improved mobility and expanded capabilities beyond just connectivity. Uh, Beyond just data connectivity, offer support for positioning services, timing services, and so on. These are capabilities that will be needed for not just drones. It will be needed for enhanced MBB. It will be needed for XIR applications, edge applications. 5G Advanced will also have AI ML capabilities. And on top of that, of course, 5G Advanced will also specify optimizations for drones. The more common optimizations we specify with the 5G system and 5G Advanced, we can achieve better economy of scale, because we can see these features being implemented in more handsets and more network equipments and be available for deployments. Uh, in general, 3GPP uses that as the mantra, specifies these features as tools. So deployments can choose what tools are necessary for different deployment scenarios, different use cases, and the particular situations. Uh, in general, 5G system offers the flexible framework and the extensible framework that is necessary for different use cases. So that is the key advantage to me that 5G system and 5G Advanced will offer uh, for drones, and that is all. We can also achieve economy of scale with 5G, with the wider coverage and capacity and common optimizations.
So, Devaki, as I understand, a big banner set of features that define Release 18 as really the advanced 5G release are AI ML
Mm-hmm. Yep.
and being able to support that for applications as well as possibly within the system itself, right? As well as AR XR, where now we're looking at the haptics and tactile nature of that will further require a very stringent, low latency to make it possible. And of course, we have industry, factory automation, process control, that drive that, as well as 5G drones to uniquely take advantage of that using network slicing and non-public network, standalone non-public network. One may label them as 5G, private networks, right? Uh, and drones, as we've seen in the use case, panel earlier, uh, will actually operate in factory and warehouses, as well as cooperatively interact with possibly AGVs, indoor and maybe hybrid in some critical infrastructure like ports and airports, etc. Right. So, can you touch base a little bit on that and the timing, at least as far as we know, on release 18, and so we get a view as far as when that might be available. But absent of that, I don't know if you can just say that even before release 18, that we can already make a lot of this possible as well with what we have.
I- I- Indeed, we have the foundational features available in 5G system in release 17 already. Many of these features, as you mentioned, XR, AR, Industry 4.0, drones, they all need one common requirement. They all need low latency and high reliability. Of course, URLC applications as well. Right. And with respect to 5G Advanced timeline, 5G Advanced is expected to start, the package for release 18 is expected to be finalized in December of 2021. And RAN 1 is expected to start the work in first quarter or second quarter of 2022. The stage 2 work will commence around Q1. And we, of course, expect to see an 18 months release for the 5G Advanced. So we will expect to see around 2023. That's when the release 18 specifications will be ready.
So Depesh, as I listen to the exchange that we have so far, right? If I look at the architecture working group within the consortium, we certainly take into account, what is there in the standards, whether that's 3GPP or on the aviation side, RTC or ASTM. But we also know that certain things have yet to happen, right? With a certain timeline that we don't really have control over, right? So, as the lead on the architecture working group, can you provide us a description of how we're tackling the unique situation, and we make sure that as we frame the framework around the architecture, right, that we still at the same time open the pipeline, for innovative solutions to hand off to experimentation. And if you can also spend a bit more time as far as the challenges and how we can overcome those challenges, to achieve the objectives that are strictly within the remit of your working group.
Correct, and that's a good point, and that primarily focus of this year on architecture framework has been to meet the minimum performance standards so we can safely navigate and operate the drone over the 5G network. That is a must. We must need to support. And at this time, we feel pretty solid that the release 16 3GPP architecture and the products we got, they can meet those basic standards, the quality of service, so we can reliably and safely operate the drone over the 5G network. Now, Thierry has mentioned, and it has been brought up a couple of times here, there are a lot more other issues here. It's not that we are only creating a 5G network for drone. 5G network exists for drone and other users at the same time. Now, interference management, that's one of the big topics discussed in depth in the beginning. We drones will see things differently than what we see on the ground, and that's going to cause a lot of problem. How are we going to fix those problems? So that's one example. Second thing we are right now tackling is on the positioning and location thing. Yes, those features are coming, not available in release 17. So for indoor inspection and safety of the warehouse, we are already looking at those positioning solutions. We are looking at the positioning solutions available outside of the 3GPP and aviation thing, and how can we get those applications behind the data network and provide the location information back to the users. And that is one of the unique thing we want to approach with the help of the academia. And those things will be tried out very soon in our test beds. That's one example. Second example is more innovations need to happen on the drone. We are not going to stick the smartphone behind the drone and fly. We need to look into the areas, what kind of platform we can use for the drone. It may be a modem, it may be a chip. We need to start looking at that, which can fully integrate the 3GPP and the UE functions together at the same time. Another thing we all talk about is there is an ultimate goal of private-public partnership, and we need to start looking into how can we roam safely from public network to private and private back to the public. Devaki also talk about the 4G and 5G coexist. That will happen all the time. We need to start looking into that also in the next year, that how can the drone roam safely within those two networks. Other than that, applications on the drone. There are a lot more applications we can enable, which just needs a transport service, which can really enable a lot of use cases. We are considering for example, the packet delivery use case. What kind of video streaming application for either packet delivery or emergency response? Emergency response is a really unique one, where drones are flying near the hazmat incidents and trying to stream the data. We can start make use of AI ML based technology, either use those video for surveillance purpose or for the navigation of the drone, so that application development and enhancements can happen while we are waiting for 3GPP and other stuff to happen at the same time. Yeah.
Okay, so looking at the priority use cases that we have thus far, as well as what it looks like, a sound, architecture foundation that we're working towards. At the end of the day, what matters, right, is what kind of innovative solutions that we get, which will be contributed to in the consortium, right, that will take into both simulation as well as experimentation. So at the end of all that, was the mention of, drone corridors to make sure that we can see that through, to commercialization. And as you also pointed out already, with the public-private, partnership in mind. So this is actually for you and Javed, because both of you are active in the working group that also has in its scope, solutions besides just architecture. So can you tell us, our audience, how that's actually being factored in as well, in addition to the architecture? Javed, you may be on mute if you're speaking.
Sorry, yeah. So the I think we touched upon it earlier as well, right? In addition to the architecture, and a very important aspect of our the solutioning is setting up the test beds in different locations, and as was mentioned in some of the earlier presentations, there's a new one that is being set up at New Air, which is this 50-mile or 100-mile round trip corridor. So the way we are working is we're defining the architecture, and in order to validate this architecture and solve some of the issues that are brought up during the analysis, we use simulation capabilities to simulate, actual real-world scenarios, including, including scenarios where you have multiple drones flying in close proximity. How PROCI could be used for drone-to-drone communication and support from the network itself. So a lot of different kind of problems still need to be kind of addressed, and in order to do that, what we've done is we've leveraging simulation to in order to realize the use cases, use simulation capabilities to address some of the key issues that come out of that. And then the testbed themselves, where we set up an actual functioning 5G network with actual radios and over-the-air communication, and flying real drones to validate these use cases. And so, for example, at New Year, they're going to be looking into, for example, a package delivery type use case where issues associated with flying drones for a commercial to realize a commercial package delivery use case. What are the challenges that you have to overcome, and what kind of capabilities do you need to bring into the system? All of that will be addressed in these test beds.
So, Dipesh, how do we take in the solutions? Do we have enough representation from the key stakeholders and the ecosystem that they have, across even the vertical that would use drone into the consortium, for experimentation? Because having the architecture is one, having the test bed is another, right? But there should be a flow of contributions, right, that bring the solutions for consideration. Taking also note that the academia is one good path to that, but certainly not limited to it, because we have, startups, and we have a lot of companies putting a lot of time and investment in making all this happen. But how do we bring them together and what we are looking to achieve?
So if I just want to add what Javed was talking and continue on the same topic. So for the simulations purpose, there are, let's see, let me just go back how the simulation part works. The use case working group kind of define the requirements, and other working group kind of look into the requirements and take it to the next level, create experiments. And we look at those experiments, and now we need to break the system into parts. That we are talking about drone as one part, how drones fly in a certain area, and what kind of experiments we can carry out safely. Then we also look at from the RF planning perspective, that how we can deploy our network in such a way that we have a full coverage for the drones in all the corners at certain heights, how drones will perform, what the performance requirement they're supposed to deliver. All those things are taken into account with the team we have already working on the drones on the 5G network perspective, and also on the application side. And you bring a good point, that more solutions and innovations we need from the drone operators, because they are the one we are enabling the vertical for them. They bring a lot of use cases and the business case, and we need to start exploring the applications they may want to develop and see how they perform into the 5G network. So we really need that side of the community to come on board and start experimenting the stuff, because at the end of the time, that's the end user, and they need to see how things work out. But 5G networks, there is optimization work going on. There are ORN kind of interfaces where you can create, accept, and make sure the network is optimized to support all the stuff. You can do a lot of simulation, keep it ready, but real innovations comes when the end user applications comes with on the drone and also the network, and you carry out throughout the 5G network we are building in the testbed.
Now, Dipesh, I would also include real quick drone manufacturers as well. Do you agree before we
yes, drone operators
give it to
and
the fact?
manufacturers both, yes, because the applications are being developed on the network side and also on the user side. So we need to make sure that both are part of this overall solution. Yeah. Go ahead, Devaki.
Yeah, thank you, Jay and Deepesh. Just to add to that point, I would also agree with Deepesh and add that we also need the drone operators and the solutions and the use cases also to drive the requirements needed from a 5G system and a 5G advanced perspective in order to determine what optimizations we need so that the 5G system can support the necessary optimizations, also considering those solutions and use cases, right? Of course, we do have many of these features being specified in 5G Advanced that we talked about here: ProC, side link optimizations, industrial IoT, URLC, edge applications, network slicing, and so on. And of course, AI/ML. Not to forget AI/ML. But besides that, if there are specific additional optimizations, it would also be good to know. And it would be good for drone operators and those solutions and use cases to drive those requirements as well. So this is a very collaborative exercise and a collaborative time frame where all the players should come together in these forums, work together, and address the technical, the non-technical, and the regulatory challenges, so we can enable the path to commercialization of these drones.
So as we get to a close of our panel discussion, I'd like to ask each one of you, for your final words. As we architect the future of 5G drones, what do you see as, what lies ahead of us? Noting that in the previous panel discussion, there was mention, let's say, of advanced air mobility, which, by the way, is not just moving or transporting people, but goods as well, right? Uh, do you see that with the work that we're doing and what we aim for in terms of making it happen, working with both regulators, industries, academia, and all different levels of government, uh, happen more, well, not in the very distant future, as late 1930s, 2030 or 2040s, right? What lies ahead is a challenge, and how can we meet that, in the consortium, as far as the architecture, right, and solutions that we want to bring in. So if you just can, give a quick commentary on that to close this session. Let's start with you, Dipesh.
Okay, so you already answered some part of it. There are two parts of it. As part of the consortium, we have worked together over last year to establish the process, how we create the working group, how working group works together, bring the use cases, bring the challenges, then we analyze the architecture. And the good part of that, we have spent good effort on building the 5G framework which can be easily expanded to any verticals. 5G has a lot of technologies. We do consider, based on the use case, our focus has been on the UAS. If UAS changes to V2X tomorrow or some health industry, we are need to go back and target what is needed for V2X. What are the regulatory challenges? What are the performance requirements? But the 5G network stays same. We need to focus on the Mac. Do we need to focus on the edge application? So there is a framework already in place. There is operating procedures are in place, and it makes really easy for us to start going and addressing the next verticals or next use case.
So maybe I'll go next. I think beyond just the 3GPP enhancements that are needed, what we are seeing with the with this need to support drone ecosystem, right? There are other standards bodies, there are other regulatory bodies that need to work in tandem with what we're doing in the consortium and in other bodies, right, to enable this drone ecosystem. And in order to do that, right, it's not just bringing in what features 3GPP needs to from the network side, but you need to develop standards in other bodies that need to work with 3GPP. And so what I expect to see, or what I hope to see from the consortium, is the ability to innovate, to solve challenges and be able to drive and guide changes into the standards, not just in 3GPP but in RTCA, ASTM, and so on, and be able to demonstrate the viability of a commercial drone operation to the FAA, so that they can make the changes that they need to and they have the data that they need to develop policies to support such a commercial drone operation.
Yep. So from my perspective, I also think that we should leverage this forum where we have both the expertise from the telco players, the drone operators, and the aviation experts to come together and identify the gaps and the requirements for the drones ecosystem to be successful. And as Javed mentioned, we should definitely leverage this to drive the requirements in the respective standard bodies, not just 3GPP, but also considering GSMA, ASTM, and other standards bodies to ensure that the drones ecosystem is a win-win market for all the stakeholders and, of course, at the end, for the end users.
Okay, let me just pick one question that I see from the chat. I see one from Uttara. Network slicing was referenced in 5G drone use cases. From 3GPP perspective, where does the flexibility reside to accommodate similar newer use cases? And I would also note that network slicing, besides being specified in 3GPP, goes a long way in terms of GSMA and other verticals looking to capture as far as what uniquely are required in support of those enterprises. I think, Defaki, you may be in a good position to maybe try to answer that question, because you referred to having 3GPP work with industry to include GSMA, and in particular GSMA North America, that actually I think aligns to the objective of the consortium.
Indeed. So with network slicing, of course, it can be used for having a dedicated session for a particular use case. 3GPP specified its part on ensuring that the the device is camping in a dedicated slice so that it gets dedicated quality of service and it gets dedicated isolation. And beyond that, we also have the orchestration part for the network slice, and then we have the GSMA part of the network slice and the network slice template, and the business aspects. How many users can camp in a slice? What is the data rate that a particular slice can offer a device or a group of devices or an enterprise? So we have all those tools being specified in 3GPP, and those are leveraged and can be leveraged also for the drones use case. In particular, one example I had given earlier was the C2 link, which needs a critical communication. So for that, network slice is a good solution to offer a dedicated slice for offering low latency command and control communication.
I know we're out of time, Devaki, but thank you. But just quickly adding, Intelligent Edge is one of those key toolkits, right, that we have in the arsenal.
Indeed.
Yeah.
Indeed.
So unfortunately, we ran out of time, but I want to thank my three panelists for a very engaging conversation. There's a lot in front of us, though it may seem daunting, but it sounds like we're off to a good start, and see what the four prioritized use cases and running that through the test bed onto the corridor will bring us. And of course we can always improve and enhance what we started with. But at this point, I'm going to end the session, and I'll let Laila and Jit to summarize their takeaway and what I think is a good productive day so far.
Thank you, Jerry.
Thank you.
Thank you.
Hey, welcome back, everybody. Thanks again to Thierry Klein and Jared Libano for the keynotes, as well as the panelists Dipesh Modi, Javed Khan, and Devaki Chandramouli. We really appreciate what everyone has been able to do today in contributing to our sessions. Leila, I think we have some poll results for 2 polls that we'd like to tell everyone about.
Yes. So the first poll is with the question: is your organization considering applying for a license to establish a private network? And if so, what's the primary reason? We got 63% no and 37% with the answer more autonomy and security. That was the key for the ones that were positive. And the second poll was the question was one survey found 44% of industrial companies believe connectivity issues pose a major challenge to digital transformation. Are connectivity challenges hindering your digital transformation? And so we got the distribution for responses 50% yes, and 25% no, and 25% unsure or don't know. So those were the poll responses. And I would also like to thank Jerry and Devaki, Javed, and Dipesh for this great panel that we just heard. And we would like to go to the key takeaways. So.
Yeah, let's do the key takeaways. And please, everyone, hang on. I know you'd probably want to get back to emails, but I'd like to summarize some key takeaways between myself and Leila, and then just talk a little bit about tomorrow. So for myself, the key takeaways for this whole day were really around the announcement of the open generation range with Verizon, New Era, and Nokia, as well as Qualcomm joining open generation. I also thought that Mike Rogers challenging our industry to deliver on 5G and build an economic base to what the space program accomplished was quite a challenge to the industry. And Paul did a great job of highlighting the societal impacts of 5G and use cases to 6G. And then in Marcus's panel, which was incredibly entertaining in the predictions about the future and how these 5G UAS use cases may overlap to create the impetus for solving many other vertical use cases if we speed up the adoption. What about yourself, Leila?
Yeah, so I would focus on my key takeaways from this panel that we just heard, just to try to summarize some of the things that got my attention. So I really liked that the approach that Jerry went with, highlighting that this is a complex standards environment where the aviation standards and the communication standards are different worlds, and we need to make sure that the aviation standards, which are focused on safety, and the communication standards focused on transforming industries and productivity, that we can consider those two environments together, which is a big part of the challenge we face with the drone use case, and one of the reasons why we say that this is one of the harshest ones. Also, that I have some highlights that what the architecture needs to be flexible and malleable to adapt to changes in those standards, because they are still coming. We are doing this as the standards are changing in both fronts. So this is very important to keep in mind. If it was easy, we wouldn't need to be collaborating and trying to do it together, but that's the reason why we are here. So I really enjoyed the overviews that were provided on the current status of state of standards, and the enhancements that are coming, what are the opportunities, and also on the closing remarks, I would like the fact that to say that the people mentioned that many of the things that we'll be addressing here, that we are addressing with this current framework, framework will be reusable for the new use cases. So when we look into V2X tomorrow, we'll be able to leverage a lot of what we are doing in terms of this 5G framework and how to apply. So that's the part of the acceleration process. And the need that was highlighted to innovate and propose changes in standards, not only 3GPP, but also those other organizations that we talked about. So very valuable panel. I really enjoyed it. Thank you.
That's a great summary, Leila. You brought out some great points from the last few panels here and from the whole day. So I'd like to invite everyone to come back tomorrow for our second day. I can guarantee that it'll be even better than today because we have some can't miss speakers such as Charles Clancy, the SVP of MITRE Labs, Scott Patrick from NTIA, Don Massey from DoD, and Arthur Hinneman from the FAA, and of course, Andy Thiessen, who will be kicking it off in the morning. So please join us tomorrow morning at 9 a.m. Eastern.
Thank you.